Welcome all. Hi. Welcome to another chemistry session. In this class, we are discussing some important questions from the chapter Redox reactions. Right? Okay. Can we start? Ready? Fine. We have the first question in the board. Assuming complete ionization, same moles of which of the following compounds will require the least amount of acidified potassium permanganate for complete oxidation? Which will require least amount? That is the question. Which will require least amount? That is the question. Okay. Suppose we are taking the first case. You can see it is ferrous oxalate given. I think some of you definitely might have seen. In ferrous oxalate, Fe2 plus and C2O4 2 minus, iron in the plus 2 state and carbon in the plus 3 state. Right? And you can see ferrous will be oxidized to ferric, while oxalate will be oxidized to carbon dioxide. So ferrous becomes ferric, that is oxidation. Oxalate becomes carbon dioxide, where carbon is plus 4 state, that is also oxidation. So what is the N factor? N factor is 2 becoming 3, that is N factor 1, and plus 3 becoming plus 4, and there are 2 carbon atom, plus 3 becoming plus 4, 1 is the change, there are 2 carbon atom, therefore it is 2, so it is 1 plus 2, 3 is the N factor, right? And now when you balance, what will happen? What will happen? You know, permanganate in the acid medium. So what's happening is MnO4 minus will be converted to Mn2 plus, where all of you know the N factor is 5. How 5? It is plus 7 changing to plus 2. That is reduction. Now upon balancing, we need to find the N factor to be equal. So what we do is, all of you know, it is multiplied with 3 and this is multiplied with 5. Isn't it? So we are cross multiplying with the N factor so that the N factor becomes equal, and that is how we balance it. So upon balancing, what you are getting is, it is 5 FeC2O4 interact with 3 MnO4 minus, giving products. Okay. Assuming complete ionization, same moles of which of the compound will require least amount of acidified KMnO4. So you see, 5 mole requires 3 mole. Therefore, 1 mole requires how much? 3 by 5. Isn't it? Now, for permanganate, it is always going to be N factor 5. For permanganate, the N factor is always 5. And what is changing is option 1, 2, 3, 4. This species is keep on changing. Isn't it? And this N factor, you see it is coming 3. So it is 3 by 5. And this value decides the quantity of permanganate. The permanganate required for the oxidation of each species directly depends on the N factor. N factor of that species. Okay. Now in the first choice, N factor is 3. In the first choice, N factor is 3. Now what about in the second choice? In the second choice again, ferrous will be converted to ferric. So N factor is 1. Now nitrite is converted to nitrate. Nitrite nitrogen is plus 3 state. It will be oxidized to nitrate. Nitrate oxidation state is plus 5. So plus 3 becomes plus 5. That is 2 electron transfer. And there are 2 nitrite. Therefore, it is 2 into 2, 4. Isn't it? You see that? Nitrogen here it is plus 3 state, and that will be converted to nitrate, NO3 minus plus 5 state. So plus 3 becoming plus 5, 2 is the n factor, and there are 2 nitrite. Therefore 2 into 2, 4, a total is 5. So n factor here is 3, here it is 5. So here what you got, the number of moles of KMnO4 per mole of oxalate, you got 3 by 5. Here you will be getting 5 by 5, that is 1. Now what about the third case? Third case, ferrous alone is oxidized to ferric. There is nothing happening for sulfate because already sulfate, sulfur in the highest oxidation state plus 6, no change. So ferrous is oxidized to ferric. So only n factor is 1. So here the n factor is 1. Therefore the number of moles of permanganate per mole will be 1 by 3. Here it is 3. You see here it is 3. So it is 3 by 5. Sorry, it is not 1 by 3. It is 1 by 5. 1 by 5. Here the n factor is 3 and you got 3 by 5. Here the n factor is 5. You will get 5 by 5. Here the n factor is 1, you will get 1 by 5. I mean all these are number of moles of permanganate required for oxidizing 1 mole of the given substance. So for oxidizing 1 mole option A, you need 3 by 5 permanganate. For oxidizing 1 mole option B, you need 1 mole permanganate. For oxidizing 1 mole option C, you need 1 by 5. Now what about the last one? Ferrous sulfite. Ferrous sulfite. Here ferrous will be converted to ferric. That is n factor 1. And sulfite will be converted to sulfate. Sulfite is how much? Plus 4 state. Converted to plus 6 state. Plus 4 to plus 2. Sorry, plus 4 to plus 6. It is 2, the n factor. You get 3. So here you will be getting again 3 by 5. So number of moles of permanganate required for the complete oxidation of 1 mole the given matter. Option A, ferrous oxalate, you need 3 by 5. Option B, ferrous nitrate, you need 5 by 5, 1 mole. Option C, ferrous sulfate, you need 1 by 5. Option 4, FeSO3, you need 3 by 5. So which requires least? That is the question. Which requires least? No doubt, the answer is option 3. Ferrous sulfate is the answer. Which requires most? Answer is option 2. Which among the following requires same quantity? Answer is 1 and 4. For 1 and 4, you need same quantity, isn't it? 3 by 5. For 1 and 4, you need same quantity. Maximum required, option 2. Minimum required, option 3. I think it is pretty clear. A very important question. Can we go to next? Fine. Next question. Question number 2. That is option 3. Yeah, fine. The correct order of nitrogen compounds in its decreasing order of oxidation state. Decreasing order. That is maximum to minimum. Here it is plus 5. Here it is minus 3. Here it is plus 2 and 0. The order is wrong. Decreasing order. Decreasing order. And the answer is option 3. Here nitrogen plus 5 state. Here nitrogen plus 2 state. Here nitrogen 0. And here nitrogen minus 3 state. Nitric acid, nitrogen plus 5 state. I am sure all of you know how to calculate. In NO plus 2 state. In N2 0. And in ammonium derivatives, ammonium chloride or ammonia, wherever it is, minus 3 state. So that is the decreasing order, option 3. Option 3 is the correct answer. If it is asked the increasing order, it will be option 4. Increasing order, it will be option 4. Right. Next question. Third question. Consider the change in oxidation state of bromine corresponding to different EMF values as shown in the diagram. Perbromate converted to bromate, converted to HBrO4, converted to bromine, converted to bromide. Then the species undergoing disproportionation is, I am sure you understand, an element in the minimum oxidation state and the maximum oxidation state, it cannot disproportionate. An element in its minimum oxidation state, for example, halogen bromine, -1 state. In -1 state, it cannot disproportionate. Because in -1 state, it is the most reduced form. Now it can only undergo oxidation and only act as a reducing agent. While in the maximum oxidation state, it is maximum oxidized form. It cannot further oxidize. It can only undergo reduction and only act as an oxidizing agent. You see, this is the minimum state and this is the maximum state. -1 and here it is +7. So this only will act as oxidizing agent and this only will act as reducing agent, while the others may undergo disproportionation. So the answer never can be 2. 2 can never be the answer. The others can be. It can be bromine, it can be BrO3 minus, it can be HBrO. Now, which is the most suitable answer? Right? Let's see what is the most suitable answer and how you can find out. The answer is HBrO. That is the fourth choice. How you can determine that? You see, BrO3 minus converted to HBrO. BrO3 minus converted to HBrO, the potential is 1.5 volt. Now upon reversing HBrO giving BrO3 minus, you get minus 1.5 volt. Now HBrO giving Br2, the potential is 1.595 volt. Now upon adding these two, that is the disproportionation. You see, 2HBrO giving BrO3 minus and Br2. Now upon adding the two potential, minus 1.5 and plus 1.595, you will get a positive potential. A positive EMF indicates that that reaction is happening. A positive EMF indicating that that reaction is happening. You can verify in the other cases. Okay. I repeat. Now, you see, this is converted to this. The potential is 1.5. So, this is converted to that. It will be minus 1.5. And this is converted to this. It is plus 1.595. The sum of these two will be a positive EMF indicating that that will undergo disproportionation. This can go to that side and this can come to this side. That way. Now, suppose you are taking about this one. This converted to this, it will be minus, okay, 1.595. And this converted to this, that is 1.06. So, this is going to be minus 1.595. And this is 1.06. When you add, it's going to be minus negative EMF. Right? So, according to the potential data given, we can understand HBrO will undergo disproportionation. Okay? Fine. But at the same time, there are situations bromine can undergo disproportionation. It can undergo disproportionation. But the most suitable answer according to the potential data given, you can understand, it is HBrO. Okay? Fine. There is another simple way to identify. You see the potential between these two are very close figure. These two potential are very close. So it can migrate either to this side or this side easily. The potential difference you can see 1.5, 1.5, 1.5 like that. So closed potential means it can either go to that side or come to this side. Easy disproportionation shown by HBRO. Okay. Next one. For the redox reaction, permanganate with oxalate, acid medium, Mn2 plus carbon dioxide, H2. Correct coefficient of this. That is a point. You know, permanganate converted to Mn2 plus N factor is 5. While oxalate converted to carbon dioxide, this is reduction and this is oxidation. N factor is plus 3 becoming plus 4, 2 carbon atom. So it is N factor 2. So how do you do? This will be multiplied with the 2 and this will be multiplied with the 5. So it is going to be 2 here and 5 here. 2 for permanganate, 2 for permanganate, these two out. And 5 for oxalate, 5 for oxalate. So the answer is second choice. Answer is second choice. And how to balance H plus? H plus is balanced by using charge balancing. You have to, after this procedure, you have to check the charge on both sides and attach H plus as many charges as the deficiency are. You know the procedures for balancing that. Anyway, by simply looking at the coefficients of permanganate and oxalate, we are able to conclude the answer as option 2. Okay, once again, plus 7 changes to plus 2, N factor 5. Plus 3 changes to plus 4, N factor 1 for 1 carbon. There are 2 carbon atoms, therefore it is 2. So here N factor 2, here N factor 5. So this is multiplied with the 2, this conversion multiplied with the 2 and this conversion multiplied with the 5. So there will be a 5 over here and 2 over here. And you can see 2, 5, only one choice. Okay. And H plus will come 16 H plus. Upon balancing the charge, you can find out how much it is H plus. Fine. Next question. Correct structure of tribromo octaoxide. Tribromo octaoxide. An example given in the NCERT text illustrating the paradox in oxidation numbers. There are certain exceptional features observed in the oxidation numbers. To explain such paradox conditions, a few examples are explained in the NCERT text, where I am sure you have seen inside a box. This molecule is given with other examples also. And which one is the correct answer? This is the correct one. Tribromo octaoxide. Tribromo octaoxide, where the oxidation state of bromine will be coming as -2, -2, -2, so this will be +6, -2, -2, so this will be +4, -2, -2, -2, so this will be +6. So the 2 bromine will be +6 and central bromine will be +4, and you can go for finding the average. How much it is going to be? 16/3. 16/3. That is the average oxidation number getting. Okay. Next one. Fourth one is the answer. Which of the following reactions are disproportionation? First one, it is disproportionation. +1 changes to +2 and to 0. What about second one? What about second one? This is manganate. Manganate +6. Oxidized to permanganate +7. And MnO2 +4. That is also disproportionation. KMnO for heating. This is not disproportionation. plus 7 reduced to plus 6 and reduced to plus 4. This is not disproportionate. Plus 7 changes to plus 4. Only reduction. So the answer is A and B only. A and B only. A and B only. Fourth choice is the correct answer. A and B only. Fourth choice is the correct answer. Okay. Yes. Next one. Conversion of methane to methanol is oxidation. Conversion of methane to methanol is oxidation. The oxidation number of carbon increases from -2 to +2 in the above reaction. See, assertion is correct. You know, methane converted to methanol is oxidation. Right? Now, second one, let us investigate. Oxidation number of carbon increases from -2 to +2. Is that correct? You may verify. Methane. This is methane, where the oxidation number is +1, +1, +1, +1, +4, and this is -4. That is methane. So, reason is incorrect. Reason is incorrect. Oxidation number of carbon increases from -2 to +2. That is wrong. It is -4 here. And what about in methanol? What about in methanol? This is methanol. +1, +2, +3, -1. So this will be -2. Isn't it? +1, +1, +1, +1. So this will be +3, -1. Sorry. 3 plus, so it will be -3. And here it is -1, so it will be +1. So the total is -2, correct. So -4 converted to -2. -4 converted to -2. So reason is incorrect, assertion is correct. Which choice we will go for? Option C, assertion true, reason false. Option C, assertion true, reason false. Yes, exactly. Oxidation number changes from -4 to -2. Oxidation state changes from -4 to -2. So assertion correct, reason is incorrect. Next question. For the reaction between permanganate ion and oxalate ion in basic medium, unbalanced equation. In the balanced equation, ratio of number of moles of permanganate and oxalate. The ratio between this and this. Already we have done this kind. This is reduction, N factor is 5. And this is oxidation. This is oxidation, N factor is +3 to +4, already commented. N factor is 2. So reduction, N factor is 5. Oxidation, N factor is 2. So it is going to be 2 here and 5 here. Isn't it? Isn't it? 2 for permanganate reaction and 5 for oxalate reaction. What asked is ratio of number of moles of permanganate and oxalate. 2:5, option C, 2:5. N factor for permanganate, it is 5. N factor for oxalate, it is 2. How it is 2? How it is 5 for permanganate, +7 to +2, 5. How it is oxalate? Oxalate +3 converted to +4. And there are 2 carbon atoms. +3 to +4, only 1 electron transfer. But there are 2 carbon atoms in oxalate. Therefore, it is total 2. Right? Yes. So it will come out to be 2:5. Option C is the Oh, there is one mistake happened, right? One mistake happened. It is not 5. I thought it is basic medium. Oh, okay, fine. In acidic medium, what I said is correct. In acidic medium, what I said is correct. This is in basic medium. You see, MnO4 minus getting converted to Mn2 plus in acid medium where the N factor is 5. I was not aware of that particular area, or I just missed that one. Basic medium is asked. In basic medium, what happens is plus 7 converted to plus 4 and the N factor is 3. N factor is 3. And here there is no change, 2. So it will be 2 versus 3 only. 2 versus 3 only. So that is not the answer. The answer is option B correct. Answer is option B correct. You see, plus 7 changes to, it's missing there. Plus 7 changes to MnO2 plus 4. So the N factor here is 3. And this, as I said, plus 3 changes to plus 4. Plus 3 changes to plus 4. N factor 2. So 2 will come here and 3 will come here. It is 2:3, option B. If it is, so see that one word when changes, the answer will change. In acid medium, it is going to be 2:5. While in alkaline medium, it is going to be 2:3. Okay, fine. Now, what will happen if it is a, see, in neutral and alkaline medium, it will be 3. Suppose it is strongly alkaline medium, what will be the change? Find out. So 3 conditions, particularly you can verify with the permanganate. Acid medium, neutral or faintly alkaline medium. Acid medium, 5 is the N factor. Neutral or faintly alkaline medium, 3 is the N factor. What about strongly alkaline medium? Verify. Next. The simple redox reaction between Cu2 plus I minus is written like this. The values of MnPQR, that is what asked for. See, in such a question, it is very simple to go for reverse application also. See, there are some coefficients given. You can simply verify in which case the coefficient will match. In which case the coefficient will match. Right? You see, the number of copper should be equal. Number of copper should be equal. That means M should be equal to P. M and P must be equal. M and P must be equal. And that is happening in only one choice. You see that M and P must be equal. I'm just telling you one simple way to identify the answer. See, there are set of coefficients given. Which one you can select? You need not go for any balancing procedures. Find out oxidation, reduction, N factor, multiply, charge balancing, water molecule balancing, hydrogen. Nothing required. You are given with a set of coefficients. Why don't you apply the basic science? Why don't you apply the basic mathematics idea? Basic mathematics idea of a chemical equation. What is that? Law of conservation of mass. The total atoms left hand side, right hand side must be equal. So total copper atom here and here must be equal. So there is only one side, copper sulfate, copper iodide. So this copper must be equal. That means this coefficient M must be equal to P. M equal to P happening only in one case. You see here M5, P1. So out. You see M4, P1 out. M3, P2 out. M4, P1 out. And the answer is option A. Now, as a practice, you can sit and practice how the balancing can be done. Okay. And the balanced equation will be this one, copper sulfate, copper 2 plus is reduced to copper plus 1, and iodine minus 1 is oxidized to 0. Iodine minus 1 oxidized to 0, and copper 2 plus reduced to cuprous. Right? Next one. Oxidation number of iron in the complex FeCN6 4 minus present in Prussian blue is very simple. Very simple. Cyanide is minus 1 into 6 minus 6, and total is minus 4. So this will be plus 2. This will be plus 2. Option A. Cyanide is minus 1 into 6 minus 6. Minus 6 with the plus 2 only can be minus 4. So it is option A. For the reaction MnO4 minus plus Br minus giving MnO2 plus BrO3 minus, ratio of number of moles of permanganate and Br minus in the balanced equation is. How to evaluate? How to evaluate? Let's see. Here permanganate, manganese plus 7. Here it is plus 4. Right? And plus 7 to plus 4. The n factor is 3. While bromide minus 1 to BrO3 minus. So minus 1 to plus 5. So the n factor is minus 1 to plus 5. N factor is 6. Isn't it? So here 3, here 6. So this you can multiply with the 2. So here it is going to be 2, and here it is going to be 1. So it is 2:1. Option C. 2:1. What is asked? The ratio of number of moles of permanganate and Br minus is asked. Right? Permanganate plus 7 changes to plus 4. N factor 3. And bromide Br minus 1 changes to BrO3 minus. BrO3 minus bromine is plus 5 state. Plus 5 state. Isn't it? So minus 1 to plus 5. N factor is 6. So oxidation, N factor is 6. Reduction, N factor is 3. So how to make it balance? The reduction reaction you can multiply with the 2. So 2:1. Option C. Next one. X mole Fe2 plus Y mole permanganate giving ferric Mn2 plus in acid medium. The ratio of X by Y. Ratio of X by Y. Again, the similar type of question only. Ferrous is oxidized to ferric. N factor is 1. Permanganate is oxidized to Mn2 plus. N factor is 5. So this will be multiplied with the 5. So X is going to be 5 and Y is going to be 1. So it is 5:1. 5/1. Option A is the correct answer. Option A is the correct answer. Direct one. The same thing we repeated many times. Next question. Option A. 1 mole ferrous oxalate oxidized by X moles of permanganate in acid medium. X is. This already we did, right? Already we did. Ferrous is oxidized to ferric. N factor 1. And oxalate is oxidized to carbon dioxide. Right? And the N factor plus 3 becomes plus 4. Plus 3 to plus 4, 1. 2 carbon atom, it will be 2. So this is oxidation, N factor 1. This is also oxidation, N factor 2. So the total N factor oxidation, it is 3. While permanganate in acid medium will be converted to Mn2 plus, that is reduction, where the N factor is 5. So what is going to be the reaction? What is going to be the balanced equation? See, permanganate will be converted to Mn2 plus, and ferrous oxalate will be converted to ferric and carbon dioxide. And the balanced equation will carry a condition. This is converted to this, n factor of 5. This is converted to these two, and n factor is 3. So what will happen upon cross multiplying? This is oxidation, n factor 3, and this is reduction, n factor 5. So cross multiplication, you get into 5 here and you get into 3 here. So what do you get? 3 here and 5 here. Isn't it? So 5 mole ferrous oxalate oxidized by 3 mole permanganate. Therefore, 1 mole ferrous oxalate oxidized by how much? That is a question. It is 3 by 5. 3 by 5 means option A, 0.6. 3 by 5 means 0.6. Option A. So permanganate becomes Mn2 plus n factor 5. Ferrous oxalate converted to oxidation product, ferrous to ferric n factor 1, oxalate to carbon dioxide n factor 2, total oxidation n factor 3. That's all. Next. One mole N2H4. N2H4 means hydrazine. N2H4 means hydrazine. 1 mole hydrazine loses 10 mole of electrons to form a new compound Y. Assuming that all nitrogen appear in the new compound, the oxidation number of nitrogen in Y is, assume that there is no change in oxidation number of hydrogen. Children, this is hydrazine. This is hydrazine, where you have +1, +1, -2. Nitrogen is -2 state. There are 2 nitrogen with a -2 state, right? And this is losing 10 electrons. This is losing 10 electrons. That means 2 nitrogen loses 10 electrons. 2 nitrogen loses 10 electrons. That means 1 nitrogen loses 5 electrons. 2 nitrogen loses 10 electrons. And in the product side, nitrogen is in one state. There is no change in oxidation number of hydrogen and or anybody. So 2 nitrogen loses 10 electron means 1 nitrogen loses 5 electron. Isn't it? So what will be the oxidation state of nitrogen here? Here it is -2. Here it is -2. And it loses per nitrogen, it loses 5 electron per nitrogen. This is 10 electron for 2 nitrogen. Okay. Therefore, 5 electron lost by 1 nitrogen. -2 losing 5 electron. What is the new oxidation state? -2 losing 5 electron. What is the new oxidation state? Simple. It's +3. It's +3. -2 losing 5 electron reaches to +3 state. Option B is the correct answer. Option B is the correct answer. A beautiful, simple question. But a question seems to be, oh, how to do it? Simple one. See, 1 mole hydrazine losing 10 mole electron. That means 1 molecule hydrazine using 10 electrons. 2 nitrogen losing 10 electron. 1 nitrogen losing 5 electron. What is the state now? -2. How -2? +1, +1, 0, 0. +1, +1, nitrogen is -2. So nitrogen from -2 losing 5 electron will taken to what state? That is the logic. Can we go to next? Yes. Next question. Permanganate, sorry, not permanganate, manganate. Manganate 1 mole in neutral aqueous medium disproportionate to. Manganate 1 mole in neutral aqueous medium disproportionate to. Let's see. Manganate MnO4 2 minus is disproportionating to. See, product is available from the choices. Disproportionating to MnO4 minus and MnO2. Okay. Now what happens? Here it is plus 6. Plus 6 is oxidized to plus 7. So oxidation n factor 1. And plus 6 reduced to plus 4. That means reduction n factor is 2. So in oxidation, 1 electron is lost. In reduction, 2 electron is accepted. Now its matter is very simple. Matter is very simple. I'm going to give 3 here and I'm going to give 2 here and I will give 1 here. See, balancing, this is the disproportionation reaction. Balancing disproportionation reaction, it's very simple logic. How much lost, how much gained. Balance that. You see, oxidation, 1 electron lost. Reduction, 2 electron gained. Now I have given 3 here. What is the purpose? Out of 3, 2 manganese is oxidized. Out of 3, 2 manganese oxidized from plus 6 to plus 7. That means 2 electron lost. Now that 2 electron gained by the third manganese to get converted to MnO2. Simple logic. Out of 3 manganese, which are plus 6 state, there are 3 manganese in plus 6 state. Now out of that, 2 manganese will be taken to plus 7 state. So 1 each electron you are getting. 1 electron you are getting. That 2 electron released by 2 manganese will be accepted by this. And thereby plus 6 manganese becomes plus 4 manganese. I think it is clear. That's a simple logic to balance the disproportionation reaction. Okay. Now the matter is over. 1 mole of this will give you how much? 3 mole give 2 mole, 1 mole. Therefore, 1 mole give 2 by 3 and 1 by 3. 2 by 3 and 1 by 3. Which one? Option A. Option A. 2 by 3 mole permanganate and 1 by 3 mole MnO2. Clear? Yes. Next question. Option A. A compound contain atoms X, Y, Z with oxidation numbers plus 2, plus 5, minus 2 respectively. The possible formula of the compound is, again simple one, when you add the oxidation states for a neutral molecule, you must get a 0. Suppose I am taking option A. Say for example, suppose I am taking option A. I am having X2, Y, Z2. Now what are the oxidation states? X2, X is plus 2 state. So plus 2 into 2, plus 4. Y is plus 5 state. Y only 1 atom, plus 5. And Z minus 2 state, minus 2 into 2. So it is minus 4. Is it coming 0? Is it coming 0? No. Therefore, that is not the answer. So which one is the answer? Wherever you get a 0, that is the answer. When you add the oxidation states, a total you must get a 0 for a neutral molecule or the charge of the species in case of an anion or cation. So which one will be the correct answer? Option B. Option B given as the correct answer. Let us examine. Let us examine. Option B. X2. Sorry. It is not option B, I believe. It is option C, I think. Option C, I think. Option C. X3YZ4. X3YZ4. Maybe it is wrongly printed option B. This is the answer, I believe. Let us examine. Let us examine anyway. Anyway, let us examine. You see, X3. X is plus 2. Plus 2 into 3. You are getting plus 6. Okay, plus 6. Now y is plus 5, plus 5 into 2, you are getting plus 10, plus 5 into 2, you are getting plus 10, and z is minus 2, z is minus 2, minus 2 into 4, minus 8 into 6, into 2, it is minus 16, minus 16, of course you are getting 0, of course you are getting 0. This is x plus 6, fine. Y plus 5 into 2 plus 10, correct. Z is minus 2 into 4, minus 8 into 2, minus 16. You will get 0 and the correct answer is option C. Not option B, it is option C. So examine in which case you will get when the values added getting 0. That's all. Okay. Next. Again, disproportionation reaction. Disproportionation reaction. You see, this is disproportionation reaction, a very famous organic reaction. A very famous organic reaction. HCHO, formaldehyde, is disproportionating to methanol and methanoic acid salt. A very famous organic reaction, Cannizzaro reaction. Cannizzaro reaction. That is a disproportionation reaction. See, this is oxidation and this is reduction. Now, what about the second one? What about the second one? Yes, that is also disproportionation. That is also disproportionation. You can understand. This will be oxidized to CH3COOH and the same will be reduced to CH3CH2OH and these two interact to get ester. This and this, ethanol and ethanoic acid, will interact to give ester. This is oxidation and this is reduction and finally getting ester. Right? Now, S3PO3, S3PO4, PH3. Definitely, S3PO3 phosphorus plus 3 state, oxidized to plus 5 state, reduced to minus 3 state. That is also disproportionation. Answer is option D. All are disproportionation. All the choices A, B, C are disproportionation. Answer is option D, A, B, C. This is the very famous Cannizzaro reaction. This is another famous reaction, Tishenko reaction. Tishenko reaction. In both cases, we can find an aldehyde. One molecule oxidized to alcohol, another molecule oxidized to acid. In Tishenko reaction, that oxidized product is available as a ester product because alcohol and acid can interact to give ester product. Anyway, that is disproportionation reaction. Answer is A, B, C. This reaction well studied in the 12th standard topic, organic chemistry, the very famous Cannizzaro reaction. A typical example for disproportionation reaction. Next question. Which statement is correct about the following reaction? Iodine gets oxidized to iodide. Wrong. Iodine is reduced. Iodine 0 is reduced to I minus. The oxidation state of sulfur remain unaltered. That is also wrong. Oxidation state of sulfur remain unaltered. That is wrong. There is a change in the oxidation state. What is the oxidation state? S2O3. What is the oxidation state of sulfur in thiosulfate? S2O3 2 minus. So it is 2x minus 6 equal to minus 2. 2x is equal to plus 4 and x equal to plus 2. The conventional way of evaluating oxidation number, sulfur you are getting plus 2. Actually, it is not plus 2, it is average. Actually, it is not plus 2, it is average. Anyway, the average oxidation number you are getting plus 2. What about in the other case? What about in the other case? S4O6 2 minus. So it is 4x minus 12 equal to minus 2. Sulfur I am giving x, 4x. Oxygen minus 2 into 6 minus 12 equal to minus 2. Therefore, 4x is equal to plus 10 and x is equal to plus 2.5. So, the oxidation state is definitely changing, no doubt. Oxidation state is definitely changing, no doubt. So, that statement is also wrong. Thiosulfate ion is oxidized. This is called a thiosulfate ion. It is oxidized. That is a true statement. That is a true statement, as you can understand. This is the correct statement, as you can understand. Plus 2 oxidized to plus 2.5. Plus 2 oxidized to plus 2.5. So there is oxidation. The oxidation state of sulfur changes from plus 1 to plus 2.5. That is wrong. What is wrong here? It is not plus 1. Rather, it is plus 2 changing to plus 2.5. I think it is clear. Fine. Next question. Bromine disproportionation. Bromine in alkaline medium disproportionate. The number of water molecules formed per mole of bromate ion. Per mole of bromate ion when the above equation is balanced. Let us examine how we can balance it. How to balance it? Br2 in alkaline medium converted to Br minus and BrO3 minus plus H2O. Now see, bromine 0 becomes minus 1, that is reduction n factor 1. And now bromine 0 converted to bromate, that is oxidation, and n factor is 0 to plus 5. N factor is 5. So oxidation n factor 5. Reduction n factor 1. Right? So how to balance it? Again, use the idea which I told a few minutes back. 5 electron lost in oxidation, 1 electron gained in reduction. So what do? You give 3 here. 3 Br2. That means 6 bromine atom. Okay? 6 bromine atom. Out of 6 bromine atom, 5 undergo reduction and 1 undergo oxidation. 5 undergo reduction and 1 undergo oxidation. You see, 1 undergoing oxidation, it will lose 5 electron. And that 5 electron can be absorbed here by 5 bromine. So out of 6 bromine, 5 bromine, 1 bromine loses 5 electron. 5 bromine accept that electron. I think the logic is clear. Yes. So the balanced equation is, the electron balanced equation. It is 3 Br2 plus OH minus giving 5 Br minus plus BrO3 minus plus H2O. And I think all of you know how to balance the charge. Here it is 5 charge, 1 charge, a total of 6 minus charge. So it must be 6 here. 6 minus charge, 6 minus charge. And now when there are 6 hydrogen, there must be 3 H2O. Now everything is balanced. 6 bromine, 5 plus 1, 6 bromine. 6 hydrogen, 6 hydrogen. How much oxygen? 6 oxygen. 3 oxygen here, 3 oxygen here. So the entire equation balanced. And that is essentially required in this case. Because what is the question? What is our question? Look at the question. Number of water molecule formed per mole of bromate ion. Number of water molecule formed per mole of bromate ion. It is 3. Option B. Option B, 3 is the correct answer. There are 3 mole water molecule formed per mole of bromate ion. Okay? Fine. Next question. 3. Intra-redox. Which of the following is intra-redox? Intra-redox means you have learnt within a molecule, one atom undergo oxidation, one atom undergo reduction. That is called intra-redox. First one is intra-redox. First one itself is intra-redox. Nitrogen minus 3 oxidized to 0, while chromium plus 6 reduced to plus 3. So in the molecule, nitrogen is oxidized and chromium is reduced, and the answer is option A. Since there is no other combinations, we will fix A. Next. Standard reduction potentials of some elements are given below. The strongest reducing agent. Strongest reducing agent. You have been taught well in the class to identify the strongest reducing agent. You identify the potential high negative value. You identify E0 X bar Y high negative value. So first of all, look at high negative value and your answer is this species. This is the strongest reducing agent because this is easily converted to oxidized to X. So identify the high negative, high negative, high negative, and the answer is lithium, lithium. Here there is absolutely no confusion, as all of us know. Lithium is the strong reducing agent in the list. But if some unknown species are given, don't worry. Look at the high negative value and identify that species given right hand side of that bar. And if you are identifying strong oxidizing agent, go for a high positive value and identify the species given on the other side. Okay. Next. Suppose you are investigating for a strong oxidizing agent. You take E0, say A bar B, go for a high positive value and your answer will be A. Because a high positive value means this is easily reduced to this. So therefore this is a good oxidizing agent. Right? Next. Answer is lithium. Strongest oxidizing agent. Strongest oxidizing agent. High positive figure and the answer is F2. Answer is F2. Don't fall in this choice. Don't fall in that choice. Okay. Fine. So keep that in mind. Keep that in mind. If you are selecting for a reducing agent, go for a high negative value, select this species. If you are going for a strong oxidizing agent, go for a high positive value, select this species. Okay? Can we go to next? Next question. Oxidation numbers of carbon in carbon suboxide is, this is carbon suboxide C3O2 having a structural detail oxygen, carbon, 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 oxygen. This is minus 2 and this is plus 2. This is minus 2 and this is plus 2, and same atom, it is 0. So it is plus 2, 0, plus 2, option C. Option C. Oh, sorry. It is not minus 2 plus 2, sorry. It is option A, plus 2 and 0. The two carbon atoms plus 2 and the central carbon atom 0. And the average it will be 4 by 3. Average it will come 4 by 3. Next, option A, and that is the structural detail. Not a redox reaction. Option A, combustion reaction, that is a redox. Option B, catalytic hydrogenation, that is a redox. Option C, copper oxide converted to copper, that is a redox. Option D, that is the answer. This is not a redox, where you can see calcium 2 plus, calcium 2 plus, carbon plus 4, carbon plus 4, oxygen minus 2, oxygen minus 2. No element undergo a change in oxidation state. Neither reduction nor oxidation. No change. Next question. Equivalent mass of potassium permanganate with the reducing agent in acid medium is, you see, equivalent mass is equal to molar mass by n factor, that's all. In acid medium, permanganate will be converted to Mn2 plus, and n factor many times we discussed 5, so it is molar mass by 5, option B. Option B, molar mass by 5, n factor is 5. What about in neutral medium or faintly alkaline medium? What about in strongly alkaline medium? Think. Many things we have already discussed. Next. Oxidation number of underlined carbon atom. Oxidation number of underlined carbon atom. What is the problem? See, this carbon atom we are asked for. This carbon atom we are asked for. So it is plus 1, minus 2. Here it is 0. Here it is minus 1, plus 1. So the total it is minus 1. Answer is minus 1, option B. What about this carbon atom? It is plus 1, plus 1, plus 1, plus 3, and this will be minus 3. This contribution is 0. Right? So hydrogen plus 1, here minus 1. Hydrogen plus 1, here minus 1. So it is minus 2. And here minus 1, here it is plus 1. Minus 2 and plus 1, minus 1. Answer is option B. Answer is option B, minus 1. Next. 3 mole of electron per mole of the species. 3 mole electron per mole of the species. Plus 6 to plus 7. 1 mole. Here it is plus 7 to plus 2. 5 mole. Here it is plus 7 to plus 4. And that is the answer. 3 mole electrons. 3 mole electron per mole of permanganate. In the conversion, permanganate changes to MnO2. You see how many times that particular area been repeated. That shows the importance of that particular example or the related reactions. Okay, please be very careful. Next. A compound of X and fluorine found to have 53.3% xenon. The oxidation number of xenon in the compound is atomic mass all given. So find out the formula. Find out the formula. Percentage is given. Find out the formula. Once you get the formula, you find the oxidation state. It's as simple as that. You see, percentage of xenon given 53.3, percentage of fluorine will be remaining. Find out the formula. Percentage by atomic mass, you get a relative number of atoms, get a whole number figure, and you are getting 1 and 6. That means the empirical combination is XeF6. Empirical combination is XeF6. So what is oxidation state? XeF6. What is the oxidation state? Plus 6 state. Plus 6 state, option A. Right? Next. For the reaction between permanganate oxalate and basic medium, number of OH minus ions in the balanced equation is. We will work out once again. MnO4 minus with the C2O4 2 minus, you are getting MnO2 plus CO3 2 minus. Now say plus 7 changes to plus 4 and the n factor is 3, and here plus 3 changes to plus 4. There are 2 carbon atom and the n factor is 2. So what do? This is multiplied with 2 and this is multiplied with 3. You will be getting 2 MnO4 minus plus 3 C2O4 2 minus gives you MnO2 plus 3 into 2, 6 CO3 2 minus. So that part is over. Plus 7 become plus 4, n factor 3. Plus 3 become plus 4, n factor 1, 2 carbon atom, n factor 2. So this is multiplied with 3 and this is multiplied with 2. So here it is going to be 2. I forgot to write 2 here. And here it comes 3 and 6. Now, the charge on left hand side, 2 minus charge, 6 minus charge, so 8 minus charge. Charge on right hand side, it is 12 minus charge. 6 into 2, 12 minus charge. And therefore, here you need to add 4 OH minus. Here you need to add 4 OH minus in order to balance the charge. The number of OH minus ion in the balanced equation, 4. Number of OH minus in the balanced equation, no doubt option 4. Option A, 4. 4 were on the left hand side. So how many water molecule will come on the right hand side? How many water molecule will come on the right hand side? That also let us finish. So it will be 4H. So it is 2H2O on the right hand side. Now the entire equation is balanced. And the answer is, this is the balanced equation. 4 OH minus on the left hand side and 2H2 on the right hand side. The rest of things we have discussed already. Answer is option A, 4. Next. The reaction between Br2 and hot concentrated alkali. The oxidation number of bromine in the product are. Bromine with the hot concentrated alkali will undergo disproportionation reaction. And I think some of you definitely know the products. Bromine will be oxidized to NaBrO3, sodium bromate and sodium bromide. So bromine reduced to sodium bromide and oxidized to sodium bromate. And in bromide, it is -1 state, and in bromate, it is +5 state, and it is option, it's not option C, that's again maybe a printing mistake. It is option D. It is option D, -1 and +5. See, the answer is correct. Maybe there is a typographic error. It's option D, -1 and +5. Bromine 0 reduced to -1 and oxidized to +5. Right? Next. Oh, there is no next. That was the last question. That was the last question. So that was a discussion on some important questions from the chapter Redox reaction. Definitely there are questions coming from this chapter for all the exams. An easy chapter. An easy chapter. Try to work out more questions of this type. We will meet with another discussion, another chapter in another class. Okay? Bye. See you.